All right, guys, in lesson 15, we're going to talk about measures of central tendency, which is mean, median, and mode. Now, it's all about the data and statistics and what the data is saying. There are three basic functions that you can perform on said data, and these are the mean, median, and mode. The mean is simply the average of a set of numbers. All right, so you add up all the numbers in the set, and you divide by the numbers in that set. So the sum over the number of the terms. All right, the median is simply the middle term in a set of arranged numbers, and they must be arranged from low to high. And if you have an odd set of numbers, it's going to be directly in the middle. And if you have an even set of numbers, it's going to be the average of the two middle terms. All right, and the mode is simply the one that occurs the most often. Now, let me be clear though, when it comes, we'll talk about this a little bit later, but the mean is the average of the set of numbers. But if you're talking about an average overall, so as a teacher, sometimes you look, especially if you're moving districts or moving states or whatever, you might Google search and say, what is the average pay scale for this position? And it comes back with an answer that is, at least in my experience, it comes back with a number that's higher than what I normally make. And that's because they're including bigger pay scales in there. Like if you're looking at an admin position, or you're also looking at people that have been there for years. It's not necessarily starting at the starting pay scale versus people that have had some years of experience. And so the average can be represented with either the mean, median, or mode, depending on which one gives you the best outcome as far as representing the data. So that's a talking point that we'll hit on in a little bit, but just so you know. Now, if I want to find the mean of these scores for number 1, order doesn't matter. I'm just adding up all the terms and dividing by the number of terms. There are 9 terms, and if I add all these up, I get 504. And I divide by 9, and that gives me a mean of 56. So the mean of this data is 56. On 2, it says below is the list of times it took Simon to run 1 mile on 7 different days. What is the average time for the 1 mile run on these days? So you're going to add all these up and subtract, or add all these up, you get 49 over 7 days. That means he ran on average 7 minutes, a 7-minute mile. All right, it's pretty good. I used to coach softball, and we asked them to run a 7-minute mile. Now, if you're going for the Olympics, you're going to need to cut that by quite a bit, but that's good for most people. The mean of a list is 256, or not 256, but 25.6, and there are 12 items. So I don't know what the sum is, but I know I'm dividing by 12, and I got 25.6 as my mean. So if I multiply both sides by 12, you get x equals 307.2, and that would be the sum of the total items in that list. The sum of the items in the set is 761, so you got 761.8 on top, and the mean is 58.6. So I don't know what I'm dividing by. I'm trying to figure out how many items are in the set, but my mean is going to be 58.6. Okay, so you multiply both sides by x, divide by the 58.6, and so x equals 761.8 divided by 58.6, which gives you an answer of 13. So that's 13 items in that set. All right. So there's a different way we could do this. In one county, 6 farms have an average crop of 75 or 47 bushels of corn per acre. Another farm has an average of 49 bushels of corn per acre. What is the average number of bushels of corn per acre for these farms? Well, you have 6 farms on one, 9 farms on the other, so it's a total of 15. So that's going to be 6 of them. 6 of the farms have an average of 47, so 6 times 47 plus 9 times 49 over 15. What does that give you? So you can put that in your calculator, and that gives you an average of 48.2 bushels per acre. So instead of listing out 47 6 times and 49 9 times, this is something I could do, and it doesn't change anything. In a group of 15, 6 students are 61 inches tall, 5 students are 60, and the remaining students are 59 inches tall. So 6 times 61 plus 5 times 60, well, and the rest are 59 inches tall. So 59 inches. 6 and 5 is 11. I have a total of 15 students. That means I got 4 more that are 59 inches. Divided by 15, put that in your calculator, and you get 60.1 inches is the average height of the students. Okay. On a recent quiz, 3 students received 100, 4 received 90, 6 students received an 80, 5 students received 70, and 2 students received a 60. What's the average grade in that class? All right, so 3 times 100 is 300. 4 times 90 is 360. 6 times 80 is 480. 5 times 70 is 350. And 2 times 60 is 120. So you could have done it like we did in the last 2 problems, or you could do it like this. So you had 3, 4 is 7, 6 would be 13, 5 is 18, and 2 is 20. So we're dividing by 20. Add all those up, divide by 20, and you get 80.5 is the average grade in the class. All right, Tim drove an average of 27.8 miles a day for 7 days. How many miles did he drive in that week? All right, so 7 times 27.8. It's an average of 27.8 miles a day. So if I just multiply, I get the average. I get how many miles he drove that week. So that's going to be 194.6 miles that week. All right, from Monday to Friday, Brenda spends an average of 1.5 hours a day on the phone with her customers. On Saturday and Sunday, Brenda spends an average of 1 hour a day on the phone. What is the average amount of time that Brenda spends on the phone each week? Round to the nearest hundredth. Okay, so 5 days, she is on the phone an hour and a half. And then for the days of the week, or the weekend, she's on the phone an hour a day. So add those up, divide by 7, and you get approximately 1.36 hours a day for the week. Hundredth means 2 decimal places. So, all right. 10. Suppose the company employs 20 employees. The president of the company earns $200,000. The vice president earns $75,000, and 18 part-time employees earn $10,000. Is the mean the best number to choose to represent the average salary? All right. So let's talk about this. This is kind of what I was referring to earlier. So if I want the mean, this is what it looks like. I have 200,000 one time. I have 75,000 one time. And I have 18 employees. So 18 or 10,000 18 times, and I'm dividing by 20. All right, so if I get the average of that, that's going to give me 22,750. All right, the median, if I listed out all these terms, my median is going to be 10,000. And because 18 or 10,000 recurs 18 times, the mode would also be 10,000. So because of the president and vice president making so much money, the mean itself does not represent this data the best way. All right, so the average salary, either the median or the mode would better represent the average in this case instead of the mean because of the salaries of the president and vice president. Okay, so on number 11, suppose 9 students make the following scores on the test. Is the median appropriate average to represent the scores, the set of scores? All right, so first of all, let's see, they are already in order. So the mean, if I added all those numbers up, that would be 619 over 9, which gives me an average of approximately 69. Median, we'll look at that in a second. And then mode. Which one of these occurs the most often? 40 occurs twice, 92 occurs twice. So you have 40 and 92. Simply because there's two answers that aren't anywhere close to each other, all right, that's not going to be a good representation of average. But let's see, I have 9 students. So let's see, 1, 2, 3, 1, 2, 3, 4, 5. My median is going to be right there. 1, 2, 3, 4. I have 9 terms, so this is my median. So my median is 92. All right, but look, half of my grades are in the 90s and up, but the other grades are way down. They're Fs, 30, 35, 40, 40. All right, so 92 is not a good representation of the average. 69 would be a better representation. So the mean in this case would better represent the average of the set. All right, so mean is the average of the numbers. But if I'm talking about the average of the set, all right, which one gives the better representation? It could be the mean, it could be the median, it could be the mode. It really depends on what's going on here. So on number 10, we found that the median and the mode would better represent the average of the set. And on 11, we said the mean would actually be a better represent that data set than anything else. All right, so for number 12, we're going to find the mean, median, mode of all of these. All right, so mean, median, mode. All right, the first thing we need to do to find the median is list these in order. All right, so I got negative 11. I got negative 7.4. I got negative 6.2. I got negative 2, 1.2, 3, 4.2, and 8.3. Okay, if I add all these up, I get negative 9.9, and I'm dividing by 8 because there's 8 terms. That's going to give me negative 1.2375. That's all the decimals. If you wanted to round to 1 decimal or 2 decimals, you want to make sure you say that, and Pearson may ask for that. All right, there's 8 numbers, so my median is going to be, let's see, I have 1, 2, 3, 4, 5. So my median is going to be between these two numbers. So I got negative 2 plus 1.2 divided by 2, and that's going to give me negative 0.4. So that is my median, negative 0.4. And then my mode is whatever happens more often. There's not any numbers that repeat, so I don't have any. My mode is empty. So that's my mean, my median, and my mode. Again, when you're trying to find your median, your data needs to be in order. All right, so for 13, we're going to do the same thing, but now we have a frequency table. So I want the mean, the median, and the mode. Okay, based on the frequency table, we can see that 1 shows up more often than anything else. So 1 would be my mode. All right, here's a quick and dirty way of doing this. There are 0 4s. There are 1 6, so I can do that. There are 2 5s, so 2 times 5 is 10. There are 3 3s, so 3 times 3 is 9. And there are 4 2s, so 2 times 4 is 8. If you add all these up, you get, if you add up the number of students, you get 20. Okay, so if I add up all these numbers, you get 33. So 33 over 20 will give me my mean, and that's going to be 1.65. My median, you can do that by listing them out. So there's 0 4s, 1, 2, 3, 4. There are 6 1s, 1, 2, 3, 4, 5, 6. There are 5 2s, 1, 2, 3, 4, 5. 3 3s, 1, 2, 3, and 2 4s. All right, so we got 20 students. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, my median is going to be right there. And so the average of 1 and 2 is going to be 1.5. So 1 plus 2 over 2 is going to give me 1.5. So my median is 1.5. So I got my mean, median, and mode. Okay, let's see. Last one. Sue made a 45, a 63, and a 70 on her algebra test. What must she make on her next test to get a C average? Okay, so students do this all the time. They're trying to figure out what they can make, what they need to make in order to keep a certain grade or make a certain grade. And so I don't know what the fourth test is, but I got the first three tests are 45, 63, and 70. I'm dividing by 4 because there's 4 tests. And she needs to equal the 70 in order to get the grade that she wants. All right, so let's clean this up. On top, it's going to be 178. And if I multiply 4 to the other side, I get 280. Because 4 times 70 is 280. And then I move the 178, I get x equals 102. So can she get it? Can she make the grade? If the test is at 100, no chance. She's going to be stuck with a D average. Okay, so there you go. That is mean, median, mode. In the next section, we'll talk about standard deviation, normal curves, and some other things. So I hope you enjoyed it, and I'll see you in the next lesson.